All right, this is the Math 1113 Zoom meeting for Friday, October 23rd. We'll go ahead and work a few problems. If Mr. Pianetta, if you want to chime in, feel free. Otherwise, we'll start working a few problems off of page 546, 6.5. Let's see, maybe we'll start with problem 5A. It's off page 547. Problem 5A, arc cosine of -1. They want the exact value. Remember, this is the x coordinate because it's a cosine. We're trying to find the angle with x coordinate -1. Look on the circle. You're at -1, 0 right here. That angle would be pi. So arc cosine of a -1 would equal pi. Can anybody hear me? All right, why don't we try 5B? Arc cosine of a half. We're trying to find angle. And really, you're looking between 0 and pi. With an arc cosine, your top half circle between 0 and pi. Oh, you're right on the edge at pi up there. Here, you're trying to find the angle with x coordinate 1/2 between 0 and pi on 0 pi. I believe you'll find that that is, with the x coordinate 1/2, you're at pi over 3. So arc cosine of 1/2 pi over 3. And you could check these with the calculator. Of course, the calculator is going to give you the decimal for pi, 3.14 something. And this will give you 1/3 of pi divided by 3. If we check with 5C, arc cosine of -√3 over 2. Find angle with x coordinate -√3 over 2. And so you'd be up at on 0 pi. Okay, again on 0 pi because it's arc cosine. Let's see, -√3 over 2. You have a reference angle of pi over 6. I'm referencing back pi over 6 there, √3 over 2 there. And so you'd be at 5 pi over 6. It should be pi over 6 short of pi, 6 pi over 6. All right. What else can we do here? Yeah, so they actually have you working stuff. Let's try 13. This is still off page 547. Arc cosine of -3 over 7. All right, now you'd be finding the angle, again on 0 to pi, with x coordinate -3 over 7. Okay, so we can do this in radian mode or degree mode. Maybe we'll do it in degree mode. So we literally punch. Divide by 7. Oh, I didn't check if I was in degree mode. I am in degree mode. Okay, I'm in degree mode. 115.38 degrees. It's just a 5 decimal place. Getting pretty anal. 5 decimal place, 37693. 115.37693. It's pretty, I won't make you do that on a test. 5 places would take you out to there. Getting a little anal there. Notice it's 0 to pi means 0 to 180 degrees. And we're between that. So if we wanted to label the triangle, your x leg would be labeled -3/7. And you'd be at 115.37693 degrees. All right, if you wanted to check, you took the cosine of 115.7693 degrees. Cosine 115.37693 degrees. Be at -0.42857137. And if I took -3 divided by 7, you get -0.428571. All right, it starts differing right here at 4286. So we're out to 1, 2, 3, 4, 5, 6 places. You get agreement to 6 places. If that proved anything to anybody. Does anybody have any questions out there?
Hey, I'm sorry. I was using the restroom. I'm here now.
Oh, okay, no problem. Yeah, I had some issues getting started anyway. I didn't get started till like 5 after. Yeah, I'm just working random problems. Do you have any questions you want to see?
Yeah. It's for the WebAssign questions.
Sure.
The ones that we were supposed to do questions 1 through 9, was that section 5.6 or section 6.6? Would you know?
I think it was section 6.5.
All right, yeah. That's what I was thinking.
Yeah.
For this one, it says find the exact value of each expression.
Okay.
And then there's 3 expressions. One of them is cosine, the inverse of cosine to -1/2. And then the other one is inverse of sine. That's going to be the -√2/2.
Okay.
And then the last one is going to be inverse of tan of 1.
Okay. All right, so these numbers are off the unit circle. So you get with a cosine, this is an x coordinate. So they're trying to find the angle with x coordinate -1/2 on 0 to pi. Our cosine is top half circle. If you picture this, -1/2 would be into the second quadrant. Draw your angle. You're kind of referencing it back to the first quadrant with 1/2. And your reference angle is pi/3. Remember, 60 degrees. Your you're steep enough that your x coordinate shortened to 1/2 and your y coordinate is √3/2. So your reference, and we lost anybody, so your reference here is pi/3. They usually want these in radian mode.
Yeah.
Have we lost anybody for that? We haven't given you the answer yet. Your answer.
My calculator's out of battery. I'm about to grab another one. Sorry.
No problem. Your answer is going to be 2 pi over 3. Because you're pi over 3 short of pi.
You said it's because I'm pi over 3 short of pi.
Right.
Oh, okay.
Yeah. At x coordinate negative a half, your reference is pi over 3. And so coming around from the x-axis, you're at 3 pi over 3. So you're pi over 3, basically you're going pi over 3, 3 pi over 3 minus pi over 3 is 2 pi over 3. To give you some confidence in this, you can punch it on the calculator and you're going to get the decimal for 2 pi over 3. But it's asking for exact, so it doesn't want the decimal at the moment. If you punch second, see, I'm in degree, you want radian mode. So mode, radian mode. If I go second cosine, second cosine, there we are. 2, it's negative a half, my fault. Negative 1/2. Second cosine, negative 1/2. All right, there you are, punched. Okay, so when we hit enter, I get 2.0944, say. Off calculator. Arc cosine of negative 1/2 is 2.0944. If I punch 2 pi over 3, if we don't get 2.0944, I'm going to go quit on the spot. I've frozen. Okay. Trying to come back. Okay, here we are. 2 pi divided by 3. And there you are. Did that give you any confidence in it? Any more confidence in it? Or is it all just gibberish?
No, I kind of understood a little more. Once you put it back in the calculator, I can find it like the same way, you know.
Right. But a lot of trig is about finding these exact fraction answers off the circle, even though you really never use it in the real world. Real world works in degrees. Did you want to see the next one?
No, I can probably do the next one on my own since I kind of got it from the other ones.
You want to try the arctangent?
What was that?
The arctangent of 1 you mentioned. You want to try that one?
Yeah.
Okay, so with a tangent, this is your y over x. You're trying to find the angle with y over x equals 1. And you're on the right half circle. You've got the domains and ranges of these memorized. You see the kind of crap I carry in my head? Meaning you're between pi over 2, but it's just strictly less than your x less than pi over 2. Sine, they're less than or equal to. And so what happens is, if y over x equals 1, your y equals your x. That happens at the coordinates were root 2 over 2 and root 2 over 2. If you want it in degrees, it was 45 degrees, but I think they're going to want it in radians. That was 1/4 of pi, pi over 4. So that's this answer, pi over 4.
So for the first and second one, aren't they both 2 pi over 3?
No, I don't believe so. your arc sign's on the right half circle. See, 2 pi over 3 is into the second quadrant. So that's top half circle. Arc sign's also going to be on the right half circle. Let me separate this.
Oh,
So you're looking for a y coordinate of negative root 2 over 2. So that's going to be down here. Zoom meeting. So that's going to be down here, negative root 2 over 2. And your reference is also going to be pi over 4. But you got to report it on negative pi over 2 less than or equal to x, less than or equal to pi over 2. And so that's going to be a negative pi over 4. Your answer is going to be a negative pi over 4. Sorry if I'm getting too jumbled.
no, you're good. You're good. So negative pi over 4, would that work as the answer? Would we have to go even further and get the radian, like decimal answer?
Well, it's not really well. This came off WebAssign, right?
Yeah.
So
I just want to put it in.
Yes, it just kind of depends on what they ask for. If they ask for exact answer, then they want this. If they say approximate it to so many places, then yeah, they want you to divide it and give the places.
Okay. And for the last one for 10, you said, I'm sorry, I just can't see the answer. Is it pi over 4?
Yes, right here. That one's pi over 4.
Another question I had was one of these that's kind of jumbled up. It said find the exact value of the expression, and this has tan of inverse of sin,
Okay.
and then of square root of 3 over 2.
Okay. You could do this one off. So that's a circle value. I'm going to do it the more general way. You can label it that way. It'll work for any number. This is going to be your opposite, and this is going to be your hypotenuse. So if you label a triangle, so you remember these are angles. Arc anything's an angle. So if you put that angle there, opposite's root 3, hypotenuse is 2. You call this side, say, x, or u for unknown. You know, x squared plus root 3 squared would equal 4 squared. I'm sorry, 2 squared, my fault, 2 squared, which is 4. Right, we losing anybody?
No, I'm getting it still.
Okay. So then x squared plus 3, this would be 3 equals 4. X squared would equal 1 because you move the 3 over, and x would equal 1. Square root of x squared, square root of 1 is 1. Yeah, I could use plus or minus 1, but off the triangle, we just use 1. So when I want a tangent is opposite over adjacent. So it's going to be root 3 over 1. Opposite over adjacent. Or root 3. That's the answer. And you can punch this on a calculator. Well, you can punch it exactly like this, and you'll get the decimal root 3.
Well, if I get the decimal like that, is there any way I could change it back into
No,
this answer form?
no,
Or
no calculators for, see, root three is an irrational number, it goes forever. So
okay.
you can't swear there isn't some calculator out there that could take, so many digits of it and, oh, that's root, give you back root three. But there, there are on the calculator, like there is a point, like 0.5, and there's a to fraction button, and it will give you 1/2. But it's pretty much got to be nice, clean, terminating decimals.
Some easy ones.
Yeah, easy ones. Have you ever seen that done? It's on here somewhere. I never do
Oh
it.
yeah.
Okay. But no, root three is
I
nice,
was
nice and clean.
I think I got just one more I couldn't figure out.
Okay.
This next one is inverse of cosine
Of cosine
of 7 pi over 6.
over 6. Okay. If you not gonna be able, this is not 7 pi over 6. Do you understand why?
Is it because it's in the cosine parentheses, or does that not matter?
It's out of domain. Your domain of cosine is 0 to pi. And you see, this is bigger than pi. 6 pi over 6 would be pi. So 7 pi over 6 is bigger. That's where these things get tricky. As a general rule, these are supposed to undo each other and give you what this is, but that only works for values in the domain of what this is. All right, so the way we got to do this in 2 steps. Step 1 is cosine of your 7 pi over 6. All right. If you go off the circle, 7 pi over 6, be at pi, you're going to be at 6 pi over 6. 7 pi over 6, this is pi over 6. For a reference there. We lose anybody?
No.
Okay. Well, at pi over 6, see, that's 30 degrees. If you remember your reference up here, that's where this is pi over 6. And your x leg, it's not negative, x leg is root 3 over 2. That's 30 degrees. And you're shallow enough, your x leg is long at root 3 over 2, if it'll catch up. Please catch up. There it goes, trying. I scribbled out that negative. Yeah, it went unstable. Okay, here we are, root 3 over 2. I don't know if you can hear me. It says I'm unstable. Can you hear me?
I can hear you now.
Okay. So you're at 7 pi over 6, which means your triangle is reflected into this quadrant. This is going to be negative root 3 over 2. By itself, the cosine of 7 pi over 6 is negative root 3 over 2. Questions about that?
No.
So you're going to substitute that in. And you're going to find step 2 here. Step 2, you're going to find arc cosine of negative root 3 over 2. Again, on 0 pi. Top half circle. So that's the angle. That's the angle with with x coordinate negative root 3 over 2. Well, you might think it's the same picture. Gee, I've got it, but no, you don't. This is not on 0 to pi. It literally, it is very similar picture, but the triangle's up here with the same x leg, negative root 3 over 2. Reference is pi over 6. And you see how you're pi over 6 short of pi?
Yeah.
Coming around here, the answer is going to be 5 pi over 6. So you actually should get 5 pi over 6. To give you some confidence in it, we can punch it exactly like this, get the decimal, and you get the same decimal for 5 pi over 6. You want to see it punched?
Sure.
Okay. So on calculator, arc cosine of 7 pi over 6, and you're going to want to be in radian mode. Yeah. Cosine 7 pi divided by 6. All right, see that? You're going to punch it exactly like it's written on the paper. I'm in radian mode. Yep, radian mode. Enter. I'm getting 2.618, we'll call it 799. All right, we're going to punch 5 pi divided by 6. I like a little drum. I'm going to give myself a drum roll. I like a little drum. And there you are. Did that give you any confidence in it at all, or is it all kind of gibberish?
It was kind of like the first one, right? When we kind of checked back on it.
Right.
Yeah, it kind of reassures me a little bit.
Okay. But yeah, it's
So
not.
the final answer would be 5 pi over 6. That's
Right. That's the angle with the same x coordinate, but on 0 to pi.
oh, like 0 to pi. Okay, is that so? You mean the top half circle?
Top half circle, yes.
Oh, okay.
Yeah, that's the way I kind of try to remember it. An arc cosine is top half circle. Arc sine, arc tangent are right half circle.
I think I probably have one last question.
Okay, sure thing.
And we just had to do one question one from section 6.6, correct?
On WebAssign, yes.
Yeah. This one says, given the function models the displacement of an object moving in simple harmonic motion.
Right.
And it says find amplitude, period, and frequency.
Amplitude, period, frequency, and what was the function?
Y equals negative cosine of 0.4 t.
Okay, so it looks like this.
Yeah.
Okay. So amplitude.
Amplitude is -1, correct?
Very close, but not quite. This. Amplitude is 1. It's the absolute value of -1, which is 1. Yeah, it's tricky. They always take amplitude.
Yeah, because they already have a negative there. So like they already kind of, messed me up.
Just quick, a cosine does this, pi at the y-axis, and they just want the distance from the center up, which is 1. Now this one's negative, so this exact one's actually going to be down. It just means it's flipped down. But the actual distance is still 1. Yeah, so watch for that. If you have a negative in front, your amplitude's positive, that number. Can you hear me?
Oh yeah, I can hear you. Sorry.
So yeah, they always take the amplitude to be positive of that. Are you ready for period?
You said period.
Yeah. Are you ready for period?
Yeah.
Okay. Period is taken to be 2 pi, again, over that coefficient. A couple sections ago, they called it K. But that was just kind of generic y is x numbers. Here, this is called they use W for the letter. It's the angular frequency. But it's still 2 pi over that. Did they say to approximate it?
No, it doesn't say anything about approximating or exact answers.
All right, well, I guess you could punch it out the whole thing, or if you want to go 2 divided by 0.4, actually 5. It's 5 pi. That's the exact. 2 divided by 0.4, you get 5. Did it 2 divided by 0.4 is 5. So your period is 5 pi. And they wanted frequency.
Yeah.
All right, you just invert the period. It's 1 over period. So that's 1 over 5 pi. So if you wanted decimals for these, 5 pi, 15.708, and 1 divided by parentheses 5 pi, 0.063666. Period is the time that this is going up and down, etc. It actually looks like this if you wanted to see it. Maybe I should show you the exact graph rather than just guessing. Did it say graph it?
Yeah.
Oh, it did. Okay, so let's graph. We want to be back in radian mode. Let's see. Yeah, we are in radian mode. Okay. So if I graph it, I get negative cosine of 0.4 and use x on the calculator. You theoretically could use t, but you'd have to find alpha t somewhere down the page. I always use x.
All right.
So window, yeah, this is a messed up window. Negative 10, 10, 1, negative 10, 10, 1. Okay, go back to standard window. It's a little small, but yeah, it's really stretched out on this window. Wanted to see
Yeah,
it.
but now I got it because you can just find it with the frequency, right? Since it's like 5 pi, just go until where it stops at 5 pi.
Right. Yeah. In effect, it's going up and down like this. If you start from the y-axis, starting low here through the 1, that's going to be your 5 pi. That's a period, 1 period. It's the time for 1 cycle, which is 5 pi. Think a period is time for 1 cycle. This is in, say, seconds per cycle. So it takes 15 seconds in 1 cycle. Our frequencies stretch it back to 1 second. This takes 15 seconds. If you go back to 1 second, you're getting 0.03. This is in cycles per second. My degree's in electrical engineering, so I'm kind of used to this. They use hertz. You ever looked on your radio and you see an MHz? That's megahertz. Yeah. Your radio, if you listen to FM radio, that's in millions of cycles per second. They're broadcasting over radio frequencies that are in millions. So they're going up and down millions of times in 1 second. Oops, I have a call. Okay. So, let's see. Uh, So in effect, you're getting, yeah, you're getting 0.06 hundredths of a cycle, 0.06 cycles in just 1 second. You know, see not much of the cycle in 1 second on this one. It's taking 15 seconds. Your power out of your outlet that powers everything is probably way more than you wanted to know. But you know
I don't know.
your power when you plug something in the wall, that's 60
Yeah.
hertz, which means 60. It's going up and down 60 times in 1 second.
Oh, okay.
In Europe, this is in USA, good old USA. In Europe, it's 50. Their power's on 50 hertz, which is why you can't take a hair dryer or something. You go to Europe,
Oh,
you can't plug your
yeah.
American hair dryer into an outlet in Europe because it's the motor in the hair dryer is working on 60, but Europe's 50. So they sell converters.
Yeah.
Again, that's probably way more than you want to know, but
No. I'm actually doing I'm going into like a software development and computer stuff like that. So I need like a little background, technical and engineering type stuff anyways.
well, you also get this in physics. They'll go over this in physics too.
Oof. Yeah, I heard physics was a little tough, so
Is there anything else you want to know?
that was pretty much my last question.
Okay. Well, we're about 45 minutes. So if you've got anything else, be happy to do it. Otherwise, I guess we'll call it.
All right, appreciate it. I appreciate you coming in today.
Yes, absolutely. Appreciate you coming out early on a Friday morning. Thank you very much.
Of course. Have a great day.
Okay. Same to you.
Thanks.